The next data structure that we are going to cover is the binary search tree. So, what is a binary search tree and what is it useful for? A binary search tree is a collection of nodes that are all connected together in a certain way. Each node in a binary search tree will have up to two child nodes, a left node and a right node, and each node will contain some data or a value, similar to our linked list. For this course, we are going to focus solely on binary search trees that take in numbers as a value, but of course, you can make a binary search tree that holds any data type as a value if you wanted to. The way our binary search tree works is that all of the left nodes will be of lesser or equal value to their parent node, and all of our right nodes will be of greater value than their parent node. So, for example, if we start with a root node of 50, and we want to insert the value 30, it will become the left child of the root node. If we want to insert a value of 100 now, it will become the right child of the root node. And this pattern just continues all the way down our tree. So if we wanted to insert a value of 75 now, we would say, is it greater than 50? Yes. Can it become the right leaf of 50? No, because 100 is there. So now, is 75 greater than 100? No, it is not. Can it become the left branch of 100? Yes, because there is not a child node there. Great, that is where 75 goes. And we could continue. If we wanted to insert 110, it would go here. If we insert 105, it will go here, and so on. Each left node is less than or equal to its parent node, and each right node is greater than its parent node. So we have the basic outline of our binary search tree here, but one thing that we are going to change is calling all of these elements nodes. Instead, we are going to make each one of these elements its own binary search tree. If we think about this for a minute, it will actually make a lot of sense. Each node in our tree is basically a subtree. It itself is a root node with up to two children nodes, which makes it a binary search tree. This is a binary search tree. This is a binary search tree. This is a binary search tree of only a parent node and one child node. This is a binary search tree, and so on. So that is how our binary search tree is going to be organized. The functionality that we want to put on our binary search tree is that we want to be able to insert values into it, which will essentially be like adding a new binary search tree to our root binary search tree. As an example, if we start with this binary search tree that has a root node of value 20 and insert 10 into it, we will place a new binary search tree with no child nodes at its left branch. We will also have a contains method on our binary search tree that will take in some value and tell us if that value is in the binary search tree or not. We will also want a depth-first traversal method and a breadth-first traversal method on our binary search tree, each of which are simply ways of traveling through the tree, or traversing through the tree as we call it, and touching every node. The difference between these two methods is what pattern we traverse the tree in. In depth-first traversal, we will start at the top and follow each branch all the way down to its bottom, as you can see in this diagram. In breadth-first traversal, we will also start at the top, but we will go across each level before moving down to the next level, as you can see in this diagram. As we touch each node in the tree, we will be running some function on each of them. In our case, we are going to simply log out the value of each node, but you can of course perform whatever function you want to on them. And that will be our binary search tree. Great. Now, it might look like a lot, but we will break it down step by step and be pros at binary search trees in no time. Before we start coding our binary search tree, we need to cover an important topic, recursion, because binary search trees are very recursive structures by their very nature. So that is what we will cover in the next video.